Okay, so this is problem 3.1.88, and they tell us that a rancher with 100 meters of fence intends to enclose a rectangular region along a river, and the river is serving as a natural boundary, so you're not going to put any fencing along the river, and they want us to find the maximum area that can be enclosed. Okay, so the first thing that we should do is give ourselves a little bit of a picture here so we can understand what's going on. So we've got a river, and this is serving as a natural boundary, so we're not using any fencing along there. And then we're going to be building a rectangular enclosure that butts right up against that, okay? And we want to actually know what's the maximum area with 100 meters of fencing, okay? So what I'm going to do is I'm going to go ahead and I'm just going to let the width here be x. And if the width is x, and we know that we have 100 meters to work with, then, you know, I've got 100 meters that needs to be used in and amongst these three sides. So this side right here, the length, would actually be the total, which is 100 minus whatever I'm using on these sides. So x is the amount that, so we're just going to let x be the width here of this rectangle, and then whatever we use here and whatever we use here, we would subtract from the 100. Excuse me. We would subtract from the 100 to figure out how much we have left to use right here. Okay, so this gives us a length of 100 minus 2x and a width of x, and we know that area is length times width. So our area formula, and I'm actually going to write this as a function of x, is the length, which is 100 minus 2x, times the width, which is x. Okay, and so if we just multiply that out, we're looking at negative 2x squared and then plus 100x. So I'm just distributing the x and then actually just rewriting it into a standard form there. And so what I'm going to do now is I'm going to go ahead and find the vertex because we're trying to maximize this. So we need to find basically the vertex, both coordinates of the vertex. We're going to start with the x, and then when we plug it back in and we find the y coordinate that corresponds to that x, that's going to be our maximum value, okay, because we're looking at something that's parabolic here. And it's a concave down parabola, so we know that concave down parabolas have a maximum point at their vertex, okay? So to find the vertex, x is equal to negative b over 2a. Remember that b here is the coefficient of x and a is the coefficient of the x squared. So when we plug those in, let's see if we can still see it there. Okay, so when we plug these values in, we're going to be looking at x is equal to negative 100 over 2 times negative 2. Okay, and if we simplify, this is a negative 100 over negative 4, which is then 25. Okay, so if I want to then find, excuse me, the y coordinate that goes with that, I'm going to plug that 25 back into my function, and I'm going to be looking at a negative 2 times 25 squared plus 100 times 25, and 25 squared is 625 times negative 2 is actually negative 1250, and then this is 2500. So you end up here with a maximum area of 1250. And the units here are meters, so this would be meters squared. Okay, so that's it on that problem.